Thank you. So hello, everyone. My name is Olivier. You may know me from a few open source projects like Weaver Test or this little VS Code Scala search VS Code extension. And today I'm here to talk about the Smithy interface definition language and the Smithy4s Scala library. So before I dive into what those things are, I need to sort of talk about where I'm coming from with this and what's the problem that those things are trying to solve. Why should we bother? So I work for a very large company. The most discerning amongst you might guess which one. And that company is sort of divided into many subsegments, which themselves are organized into many, many teams and sub-organizations. And those teams may maintain pieces of software that are part of a large platform. And those pieces of the platform need to communicate with one another. And every single time you have two components that need to talk to one another that are crossing the boundary of a team, it's a costly exercise. It's costly because there's negotiations that need to happen as to what data transits over the wire, whether it's over some request-response protocol like HTTP, or whether it's over some asynchronous mean of communication, such as data, distributed logs like Apache, Kafka, or AWS Kinesis. Those negotiations involve like the decisions of what the data needs to transit, and that has consequences over the access patterns in your databases and stuff. And so it takes time to get things right, and it takes time for the teams to agree on what the things should look like. It's even harder of an exercise because teams tend to not use the same programming languages. And so there tends to be discrepancies in the sort of terminology that people use in order to represent things, in order to talk about the nature of the data and how it's supposed to be modeled, etc. So really what we're trying to, or the thing that the Smithy IDL is trying to help is like to facilitate discussions, and in particular discussions at scale. So the challenges of solving this discussion problem, this negotiation problem, well, there's a few concerns to take care of. There's the what. There's the what is the data that you want to send over the wire? What is the data that needs to be communicated amongst different platform components? And that is a sort of semantic level kind of concern that doesn't really, it's really business-centric is what I mean. It's like, at the business level, what is the data? What is what I'm trying to represent in terms of business terminology? There's the how, and that's everything that is protocol-specific. That's what kind of serialization do you use in order to transform the data into some payload that is going to make its way onto the wire via HTTP or whatever. So it could be JSON, it could be protobuf, it could be some other kind of serialization mechanism. And there's also the transport that needs to be specified, like are you using HTTP, are you using gRPC, are you using something else? And whatever the solution looks like, you really, really want to make it easy for things to be automated so that really as little effort is required from the teams in order to get those things actually implemented. So at work, we've identified the Smithy interface definition language as a good axis of solution for these problems. So don't worry about the code there. I'll explain it in a minute. But so Smithy is the interface definition language that AWS uses. It's their interface definition language. It's not somebody, it's not some individual who made it as a pet project or something. And that's quite interesting because even though large companies don't have the monopoly on good ideas, having the backing of a large corporation in order to grow an ecosystem, which is usually the case when you have a new interface definition language. You want to sort of have an ecosystem growing out of it. That goes a long way. Like, it's really, really important to have this kind of corporate backing, because you don't want to invest into something that is going to die in a couple months or something. So AWS has got like tons of services. They've got probably hundreds of publicly available services like S3, DynamoDB, etc., Kinesis. And internally, I think they've got in the range of like thousands, if not tens of thousands of services. So they need something to sort of help with this massive amount of platform components that is inherent to their platform. And something that's really interesting about Smithy is that it's protocol agnostic, in that it's possible for it to be used in various different contexts. I'm going to sort of explain that in a little bit. And lastly, like, it's a very, very tractable interface definition language, in that it's a lot easier to manipulate and understand than a lot of what the competing products do, like OpenAPI, for instance. So that really helps building tooling on top of this interface definition language. So there's going to be three parts to this talk. I'm going to talk about the Smithy language itself. I'm going to talk about like how to consume Smithy files into some JVM program. And then I'll do a little demo of the Smithy4s library that we're building at work. And yeah, so let's dive into it. So Smithy comes with it is a metamodel. A metamodel is a set of building blocks that lets you create models. So you can think about the Lego metamodel as being the set of all the Lego pieces that were ever created by the Lego brand. Or you could think about, you could sort of have sub-metamodels that say, okay, I'm going to just focus on a few Lego pieces and only allow my the people to sort of build models using those things. And so the more constrained the metamodel is, the easier it is to integrate with various things, because it sort of lowers the surface area of the language, and therefore it's easier to implement into different target languages or whatever. So at the very root or leaves of your models, you always have primitives. Those are the most atomic building blocks that you can have in a model, and that's the exhaustive set of primitives that Smithy provides you with. So you got the usual strings, numerics, booleans. You have a timestamp primitive, which represents like a point in time. You have a blob primitive, which represents an arbitrary blob of binary data. And you have a document primitive, which is basically representing a structured piece of data that abides by the same semantics as JSON. Then, in addition to those things, you can actually name or create your own, not primitive types, but you can create your own simple shapes. Like, you can create your own primitives by saying, okay, I've got this business level concept that is a user ID or an account ID or whatever, and you can give those things names in the Smithy IDL, which is pretty similar to like Scala type aliases or opaque types or things like that. Then you have collections. So you have only two sort of canonical types of collections in Smithy. You have lists and you have maps. So there's no like generics in Smithy. It's actually really nice from somebody who maintains tooling that's built on top of Smithy to not have generics, because it simplifies the implementation a lot. And there's some nice aspect to having or to being forced to name everything, because it kind of guarantees that you'll be able to support languages that may not have support for generics, like Go or whatever, even though Go is getting generics apparently. There you go. You have structures. So structures are basically the bread and butter of any IDL. Like all IDLs tend to support structures. It's basically your product types. It's the It's the construct that lets you say, OK, I've got this piece of data and that piece of data and that other piece of data bundled together. So structures are a set of fields. Each field has a name and a target shape. And so you can obviously compose them together. You can say, I'm building this structure from this other structure, etc. Each field can have a number of constraints, and I'm going to talk about that in a minute. But you can sort of annotate the fields with additional pieces of information. Then you have unions. So unions are the perfect dual of structures. They're your co-products. So in Scala, it would be like steel traits or Scala-free enums or Scala-free union types. So you have a single way of representing co-products in Smithy, and that's union. And that's really nice that it's just like this one perfect dual to structures. Unions are a list of alternatives. Each alternative has a name and a target type. There you go. Then you have enumerations. So you have two flavors. In Smithy, you have the string enumerations. You have the int enumerations. It's a little bit annoying that AWS decided to sort of make this difference between the two because it breaks the sort of protocol-agnostic nature of Smithy a little bit. But people tend to, or developers tend to find it intuitive to be able to build enumerations like that. So it's fine, I guess. And then we sort of take a step outside of the data definition thing, and we have this additional thing in Smithy called operation, which is basically just the association of an input and output and maybe a bunch of errors. So each component of an operation is optional. If you're not providing the output, it's basically like your operation returns unit. There's actually a sort of empty structure named unit in the Smithy standard library. Oh, that's something that I should have mentioned by the way, going back a little. But yeah, like this namespace at the top of the file here is the smithy.api is the Smithy standard library namespace. So it provides you with like a bunch of primitive types and a bunch of other annotations, and I'll talk about that in a minute. So yeah, operations, it's very fundamental. It's like input, output, bunch of errors, that's it. And then you have services. And services are basically just a collection of operations that are bound together topically or in arbitrary fashions. Yeah. And that's basically it. That is very, very bare. It's a small set of constructs. It's really intuitive. It's a clean syntax that looks familiar from the point of view of, well, Scala developers, Java developers, people doing programming in object-oriented languages, usually. It's got this fundamental set of constructs that are structures and unions, which are the most important things to have in interface definition languages, because the union is like the logical OR to the problem of modeling, and the structure is the logical AND to the problem of modeling. If you have the two of them, basically you're golden in terms of algebraic correctness. But yeah, it seems very bare. Like, is that it? Like, you can express domain levels concepts with those things, but you can't really express much more. And that's sort of a segue to the actual thing that makes Smithy quite unique in the ideal problem space. So it's the Smithy traits. So the traits are basically annotations that you can use to enrich your model with protocol-specific concerns. So you can add protocol-specific constraints or pieces of information to say, when I'm using this operation that is represented with business level terminology, I'm actually going to make an HTTP call to a service using that particular HTTP method at that particular path, and I'm expecting that the happy path status code will be 200, for instance. And you'll have, in the input of this operation, you'll be able to annotate each field to say, well, this field I'm expecting to see in the path, the HTTP path of my HTTP call, and that field I'm actually expecting to see it in the query. So you have this sort of distinction, the separation from the core semantics to that are protocols agnostic and the protocol-specific semantics that are written in terms of annotations. OK. One thing that Smithy is really nice for is that those traits are actually coming with validators or coming with linters that help you write your API specifications or your protocol specification, or not protocol, but data communication specifications in a way that is going to be really guided through your IDL. You'll get error diagnostics, you'll get warnings, et cetera, to say, I'm doing something right or I'm doing something wrong. And in this slide here, what's happening is that I've got this HTTP label annotation that's commented out. And because the HTTP path here, the URI field in the annotation, references the name field, essentially Smithy is saying, oh, you've got this name interpolated segment if you're in your path, and you've got a name in your input type, name field, but I'm not able to actually bind them together. You need to have the HTTP label annotation on it so that I can actually validate the use of the HTTP annotation in your case. So Smithy traits are defined using Smithy, exactly like you define Scala annotations using Scala and Java annotations using Java. It's very natural, and that's really nice to have something that constrains the structure of your annotation. So for instance, in OpenAPI, when you add pieces of metadata to an OpenAPI construct, you're going to have this sort of unstructured or unconstrained piece of JSON that nothing validates the abidance to a specific type or a specific structure, et cetera. So you can get this preliminary validation of is my annotation constructed correctly as per the definition of its inherent structure? And you can define your own traits. So traits are not something that are just defined in the Smithy, the standard library of Smithy. You can define your own, so you can extend the meaning of your specifications with additional pieces of metadata that are going to help the building of tooling on top of those specifications. One thing that is really, really interesting as well is the fact that Smithy traits do not have to be applied directly onto the same file where the shape that they target is defined. So you can sort of import Smithy specifications from somewhere else, from a jar, from elsewhere, and you can say, OK, well, I know a little bit more about this piece of data, or in the context of my own application, I want to have this additional piece of information about that particular thing that's going to help guide the tooling. And that's quite unique. It's not something that's possible in Proto. It's not something that's possible in OpenAPI without building a lot of functionality yourself, anyway. But it is really, really helpful for any kind of code generation feature where you want to customize the code that gets generated in your application without polluting the original specification with concerns that are really related to your own use case. Right. So Smithy is a protocol-agnostic interface definition language. Really what it means is that it can support several protocols. And a protocol is basically just a Smithy trait, just an annotation that you annotate a service with to say that particular service can be interacted with in that particular protocol. So REST JSON, for instance, or you could have REST XML, which AWS has, et cetera. It sort of lets you understand what the rules of engagement are going to be when you actually want to talk to the service. So protocol, in terms of how it's defined, is basically just a list of traits that you need to take into consideration when you are actually implementing it. So the tooling builders, like myself, are going to look at this list of things and going to say, OK, in order for me to support this protocol for my users, this is the exhaustive list of things that I need to be aware of, that I need to take care of. And that's really nice, because it gives you a bounded effort for providing support to a specific protocol. When you use OpenAPI, you are faced with like an unconstrained IDL that is extremely permissive. And no matter the amount of effort you're going to put into building tooling on top of it, there's always going to be one of your users that looks at the OpenAPI specification. It says like, oh, I can do this in OpenAPI, and falls out of the list of things that you've thought about for supporting the tooling. And so when you have this in Smithy, when you have this list of things that are exhaustive, you know for a fact that this is all you need to take care of in order to have your users get proper tooling that is going to interact flawlessly with other services, other tools that talk the same protocol. So the protocol is this list of things, and it's also a sort of formal document specifying like which or what is the behavior of all those things. Cool. So that's the end of part one. Smithy is a small set of computational constructs. It's extensible by traits. You can group the traits into protocols. You can define your protocols in userland, and you can sort of capture a lot of existing things that are part of your own platform that were pre-existing into Smithy. So you sort of can retrofit existing implementations into the Smithy IDL. OK, second part, I'm going to talk about how to consume Smithy. So if you want to build tooling on top of Smithy, you need to have a Smithy compiler. Thankfully, AWS provides this Java library. So it's a set of like libraries rather than just one. It's written in Java, but it's really, really good Java code. It's very well documented. It is the kind of Java code that you would like all Java libraries to abide by, namely like they use immutable data structures with local mutation when you want like the builder pattern, for instance. It is like FP friendly. There's a lot of things that you can manipulate with like pure functions. It's quite intuitive to use, and yeah, of course, it's like Scala friendly. So it's actually great. So it looks like this. The only thing you need to pull is basically like this Smithy model library from the Maven central repository. And then you sort of start from this model construct. And from the model, you can create a model assembler, which basically like the compiler input. You configure the assembler with whatever files you want to load into the model. So there can be like several files. You can enable, disable some validation. You have a lot of control over what's going on. And when you call assemble, all the Smithy shapes, all the Smithy files are going to be sort of bundled together and analyzed in a single pass. And you're going to have this cohesive model that is basically just a flattened collection of shapes. And that assembly will run the validation so that no matter where the Smithy file was written, all the traits that are part of it are validated against the validation rules. And all the references that are part of the models are actually resolved. So when you have a shape that points to another shape, after you have assembled the model, you have the guarantee that it's actually there. So it makes it really, really intuitive to traverse, because you have this sort of strong guarantee that the model is going to be already valid. You don't have to do a lot more work in order to verify that the information that you need is actually there. You can, so yeah, as I said, you can model, or you can load models from various sources. And in particular, it's really easy to load models from jars. And in a big organization, when you want to sort of distribute models so that people can co-generate stuff into their own application, it makes it really nice. It's a lot nicer than having to deal with like Git submodules or whatever. And it's just there. Like, it doesn't seem like a very revolutionary feature, but it's really, really convenient for building tooling on top of Smithy, because you have the guarantee that it's going to be easy to distribute models across the organization. You can load them from files, you can load them from raw strings, etc., and everything is going to be mashed together into a single cohesive data structure, which, like, it's really nice for testing. It's really, really great for building all sorts of tooling. Then for the traits, essentially the way that you manipulate traits, there's two ways. The first one is that you can accompany all the trait definitions that are written in Smithy with Java pojos or case classes with a little like type class-like construct. And you can sort of query the model by saying, OK, give me all the operations that are this particular trait, or give me all the traits that are part of this operation, or give me, like, does this operation has this specific trait that I'm looking for. And once you have the instance of the trait, then you just call the method that are defined on the pojo in order to retrieve the relevant information that you want to retrieve. But you can also manipulate traits in a kind of JSON-like fashion. So if you didn't go through the hassle of defining pojos for each of the annotations that you may have defined in your models, there's still, like, the JSON value for the traits that will be available in the models. You can sort of have, you can write a lot of generic processing tools using the sort of JSON-like form for the trait values that are part of your model. All right. So that's it for, like, the Smithy as a compiler. It was a short segment. But the very nice part is that there's a lot of pre-built features that are provided by AWS out of the box. So there's the loading of the models, but there's also like a diff kind of tool or library where you can put or take two models and get the list of all differences, all the shapes that were added, all the members, all the fields that were added or removed. And because of that, you can build tooling that are going to verify the backward compatibility of your APIs, or like any kind of constraint that you want to enforce when your engineers evolve the models, etc. All right. So now that we've introduced Smithy, I'm going to talk about Smithy4s. So Smithy4s is a code generation library that takes Smithy files and produces Scala code. It's available at those addresses. We put a lot of care in our documentation. So there's a lot of features in this tool, and it would take hours and hours to describe everything. But yeah, like, have a look at the documentation if you're interested. But in addition to the code generation, we also have out-of-the-box bindings for HTTP4s. So Smithy4s is written in a way where the core library, the library that is the only requirement for the generated code to compile, this library is protocol-agnostic as well, and it is third-party dependency-free. So the core is written without any dependencies, without any bias towards a specific protocol. The generated code is not protocol-specific. But anyway, I'm going to just demo it. And I'm very aware that, like, I've explained what Smithy is very succinctly. There's a lot more to it, obviously. And I'm not going to explain how Smithy4s works under the hood, because it would take a lot of time. But just to give you an idea of what's possible to build on top of Smithy, we're going to get going. So I've generated, We have a Giterate template in the DisneyStreaming GitHub organization. So if you type sbt new DisneyStreaming /Smithy4s.g8, you can generate a quick start project for Smithy4s. I'm going to open this up in VS Code, import the build, and while I'm importing the build, I'm going to take through the sort of structure of this little quick start project. So because there's code generation involved, there's a build plugin, which is exercised during build time. OK. So yeah, build plugin. The build defines the dependency to Smithy4s HTTP4s because it's a little HTTP server. We also have Smithy4s HTTP4s Swagger because we have like one-liner to serve OpenAPI files that are translated from the Smithy specification. And the Smithy4s HTTP4s module obviously depends on Smithy4s core, which is why the generated code can compile. And that's what the application looks like. And basically from the Hello World service, so if I have a look at the Smithy specification that is inside this pet project, so it's basically just a Hello World like we've seen in the presentation. I can navigate through the file. I got like good editor features like modern navigation. I get error diagnostic. So like I showed, if I comment something, the editor is going to yell at me, oh, you're not doing your specification right, etc. And so when I open the terminal, run sbt, and compile this project, there you go, going back to the main, I can jump to the definition of like, what's the greeting? OK, so can I? OK, well, one sec, up. There you go. Cool, all right. Right, so it's basically like very intuitive. Like if we have a structure, it's going to translate to a case class. If we have a union, it's going to translate to a sealed trait. The service is written or is generated as an interface, blah, 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 blah. So if I go there, jump to the elevator service. So it's going to be a little bit scary, but it looks like this. So I've got this hello method, which reflects exactly what's in the specification with a name, parameter, town parameter, etc. Going back to here, so the only thing that we expect the user to do is basically to implement this generated interface. It is domain specific. There's no like the user doesn't have to worry about the HTTP semantics. It's thinking about the domain problem, thinking about the domain semantics, and then we have this one-liner that converts this implementation into an HTTP route, and that's it really. Like there's no other configuration that's needed from the user. We also have this one-liner that creates the Swagger UI for it. And then we serve that using the actual HTTP server. I'm going to run this. Cool. Going to go to, I'm going to open an connector window. Localhost. No, it's not this port. That's the presentation. Sorry. 9,000 docs. There you go. That's the. So for free, you got Swagger UI. You can interact with your application this way. My name is Olivier. I'm going to say send that. Get hello Olivier. Cool. And now if I, how much time do I have left? 10 minutes. Oh, nice. Plenty of time. OK, so I've got this sort of server for free. The server abides by what's in my specification, and I don't have to worry about it when I write the Scala code. I just know that I can trust the Smithy4s interpreter to do the right thing and to follow what's written in the specification, meaning the hello operation is served on an HTTP GET request. The data is required. So if, well, Swagger UI will not even allow me to not put something here, but like say I put this additional optional parameter, then the behavior changes. Now I'm going to do something like change the specification a little bit. Let's say I'm going to like change the status code to 1 for just the demo. I'm going to add an error as well. Yeah. What am I going to add? We got beef, because I don't want to say hello if we got beef. I'm going to provide a reason. I'm going to make this reason required. I'm going to add or specify that this is an error, and the error has to be like either client or server. So I'm going to say this is a server error because I'm the one who got beef. And here I'm going to say in my operation, OK, errors, cool. So we're adding this, and I could also add something like HTTP error unavailable, because if we've got beef unavailable to you, then I'm going to go to the terminal, recompile the code, something. And here I'm going to actually make use of this error to sort of change the behavior of my application a little bit and say something like, if name equals Donald, I'm not talking about Donald Duck here. I'm going to raise error. We got beef. I don't like you, Donald. And else, I'll say hello. Cool. I'm going to rerun this. All right. I'm going to, I don't even have to, in theory, it should just work, but like, there you go. 503, service unavailable. Message is what I wrote in the code. I didn't have to specify anything with regards to handling that particular error. In my HTTP routes, it's all done under the hood for you by the interpreter. The error code, the error successful code, sorry, if I go back to Olivier here, we can see like it's 201 now, so it's actually registered the change. If I reload the view, it will actually know that the thing is recognized as the 201 like status code for the happy path. All right. I think I'm just going to go back to the slides now. Where is my presentation? Oh, killing this, going back to, OK. I had slides in case the demo was not working very well. Cool. All right. So Smithy4s, protocol-agnostic code generation. We have cross-platform support, so JVM, JS native. We have cross-Scala version support. As of now, in the sort of 0.17 version of Smithy4s, you get a bunch of features already. You get OpenAPI for free. You get command line interfaces for free. You get HTTP bindings for free running on top of HTTP4s. Obviously, you could build the same thing on top of other HTTP libraries because the Smithy4s core doesn't depend on anything, so it doesn't enforce any kind of patterns onto you. Coming later, so in the next, let's say, month and a half, couple months, we're hoping to have the next version, which is going to make it easier to write integrations with the generated code. Because AWS, well, Smithy is the AWS ADL. If you know where to look, you can actually find the specification for the AWS services, which means that if you implement the protocols that AWS uses to talk to or to have the SDK talk to their services, you can implement a cross-platform AWS SDK, like pure-Scala AWS SDK, which we are actually doing. So hopefully, like in a month and a half, you can have pure-Scala DynamoDB clients that run on JVM, JS native, if you want. We're going to have support for XML, for some other bits of serialization. We're going to make it easier to sort of implement other protocols than REST JSON, et cetera. Yeah, so conclusion, Smithy is an int IDL. It really works well if you are in an organization that is trying to put the toothpaste back in the tube, that has like tons of services that aren't documented or not documented very formally. You can sort of retrofit a lot of concerns into the Smithy IDL. It's a very solid foundation for tooling, which is really, really a cost saving when you have tons of teams. And in particular, if you do it right, it really provides joy to your engineers because it takes care of a lot of layers of their applications for them, which means better velocity, better turnover, not turnover, better handling of new requirements, sorry. And yeah, like Smithy4s, we're putting a lot of work into that. And that's it. Any questions?